Good afternoon. I want to thank the Green Bank Observatory for inviting me to give this talk. Um, it's been 17 years since I was in Green Bank and thought about this project. So, going through my slides, I was reminded of a lot of things, and so I kind of changed the scope of the topic to match more what I think people would be more interested in. Some of the interesting stories that occurred during the construction. I'm always reminded of Bob Hall, the project manager, always used to say, "This was not for the faint-hearted," and I think that people will agree he was probably right about that. That looking back, there were a lot of near misses. That it's kind of a miracle that the thing got built, and so you probably know the story of how the GBT was funded, but this is for the groundbreaking. And Senator Byrd, of course, he looked at these things as campaign stops. He would use local musicians, and he would actually sing at these things. Uh, Over here in the back, there's a very interesting story of folklore about how the $75 million appropriation came about. I don't know this for a fact, so maybe George Seilstedt will tell that story. It would be interesting if he would. Back here are the people from photosynthesis, the people that made the documentary of the construction of the GBT. I think they're going to show a section of that at this conference. Over here is Bob Hall, who's the project manager. He's a very interesting character. He had been a captain in World War II, and after the war, he developed polio. He was actually treated by Dr. Salk in Pittsburgh. And he said, Dr. Salk one day told him, says, "Bob, you've killed a lot of my monkeys in the lab down there with your case." But he recovered and went back to work, and he worked for Chicago Bridge and Iron, designed the steel for the United Nations building. He later worked for Roar Aircraft, which mainly they were doing antennas to broadcast at towers and so forth. And then somehow they got into the microwave business and the dew line, and he told stories about working on those things. And then he got involved in antennas for radio astronomy. Um, uh, he was involved in practically all of the radio telescopes at that time. Uh, a lot of antennas for JPL. Uh, he's incorporated in the history that JPL wrote a history of the of their radio astronomy work, and he's got a chapter in their book. But the GBT was his main goal. That was his final project, and he wanted it to be right. This was the pamphlet from the groundbreaking, and won't bore you with all the details, but you see the plan was very ambitious. The schedule, 1995, was the first astronomical use. Construction was going to be finished in 94. We didn't quite make that. So this is kind of a personal photo, but right after the groundbreaking ceremony with all the dignitaries and everything, um, it's kind of like after the circus comes to town. Immediately after the ceremony was over, everything was packed up and hauled away, and it was like nothing left except the marker where the center of the telescope was going to be. The next morning, the excavators and all were going to move in and start digging. So we decided to have a cookout at the last opportunity in the center of the Pendle Room. And this is various members of the metrology group that I was with, and the friends of the metrology group. You'll probably recognize some of these people. The metrology group was located, our labs were located in the old 300-foot telescope building. As you see, we had a picture window literally overlooking the project. We also had a scanner radio tuned to the contractor's frequencies. And so basically we had a ringside seat to everything that was going on. We passed by it every day going down and back, plus heard all the crane operators talking as they were doing the various operations and everything. So it was really quite interesting. We had kind of a great sidewalk superintendent position there. Okay, getting to the actual construction, this is the pennel bearing. This is the pennel room to support the pennel bearing. There's a huge slab of concrete here, and you may wonder why was it so big? Because the weight was actually carried by the track. Well, actually, this was sized to carry the horizontal load, particularly the wind load. It was literally to keep the telescope from being blown off the tracks at I think it was a 90-mile-an-hour wind was the requirement. So you've got this huge pedestal buried in the ground just to keep the telescope from blowing away. This is the foundation for the track. Now, at the time, the estimated weight of the telescope was 12 million pounds. It kept creeping up and creeping up as it went, and later I'll show you when we weighed it, it was 16,727,000 pounds. So the weight had increased considerably. But the foundation, the wall looked like a T structure, where this is the bottom of the T. And after they had poured this, they decided to make the vertical portion actually wider than it is at the top. So they added another foot to the vertical section down near the bottom. Don't believe that shows up quite here, but another thing was the specifications called for the specification called for the foundation to go down to the shale. There's a layer of soil and then the shale down about 15 feet, I think it was. But it did not say that they had to be uniform, just down to the shale. Well, the contractor, Radiation Systems Incorporated, the RSI, that was the initial contractor. It changed hands a number of times. They kept getting bought by other companies, Comsat and Vertex, and I forgot who the last one that bought them. But anyway, it changed hands a couple of times during the process, but the crews all remained the same. They left this project alone, even though they bought the parent companies. But they made the track even all the way around, which turned out to be fortunate because of the symmetry. If different parts of it had been different thicknesses, you'd have a different spring constant, so to speak. But as it turns out, it's uniform all the way around, and that was just a fortunate thing. Notice these grade beams. There's still 4 grade beams exposed that you see, but there's 4 more underneath the ground that you don't see anymore. This was really designed to be a sturdy pennel room, to, like I said, to take care of the horizontal load of the wind on the telescope. After the project was winding down, we scavenged some pieces from their scrapyard before they were all hauled away. What we got here is the 2 largest and smallest pieces of structural steel. You see the bottom one there is 2-inch thick plate, 36 inches square, and the lightest part is 8-inch tubing. So when you're up on the very top of the telescope, that's what you're being supported by. Something that looks almost like a beer can. One interesting aspect from the metrology standpoint is the wheel system. there are a number of features here that might go undetected, but when the wheels were turned at the factory, they were cut on a taper so that the wheels are actually cone shaped. If you were to just have one of these wheels and rolled it around, it would naturally roll in a 105-foot radius. So there's no steering needed to keep the wheels in line. And the way that was set up, on the end cap of the wheels, there is, right here, you take this cover off, the shaft is actually bored out all the way through. And in the pintle room, there were openings. There were 4 openings that were left in each quadrant, one in each quadrant of the pintle room and the door opening. And so you could slide a alignment telescope into the bore of the wheel, which put it right on the axis of the wheel. You sight through the telescope into the pintle room to a point that's at the same elevation as the track and in the center of the pintle room. In the pintle room, in the floor of the pintle room, there's a brass marker with a punch mark in it. That's the main coordinate that the telescope was built by. Everything worked from that brass benchmark inside the pintle room. So the way they set this up, they put this truck up here, and they align the wheels to hit that target at track elevation in the pintle room. And there were some adjustments that could be made to get that line perfect. Then the same thing with the other truck. Then when they built the corners, they put this big weldment on top of that, and this is sitting on basically spherical bearings. This is just basically like a crescent-shaped male and female part that this just sits down on. And the weight of the telescope holds it down to the trucks. This is called the wiffle beam. And if you notice, well, let me go one other thing. The suspension for the wheels was very critical. You could not have springs or anything in the wheels because that would affect the pointing of the telescope. So the wheels, in effect, control the pointing of the telescope. And so you don't really want anything like shock absorbers or springs that could change. On the other hand, you want it to accommodate some motion in case it runs over something, like, for instance, a 1-inch round disc, which we tested inadvertently. So there has to be some compliance in the system to be able to move without breaking things. So the suspension is based on these flex plates that are purely in tension, or purely in compression, excuse me. And this allows the wheels to wobble back and forth and flex these plates, but it doesn't change the height of them. And at the same time, with these spherical bearings, one end can raise up and the other one drop down or whatever and pivot on this line between this bearing and the one on the other side. There was a tight specification on how much you could misalign, like when you lift one of these to service it. They didn't want a lot of twist in this corner weldment. And so the bottom line is it's proven to be a very good system. This concludes the 15 minutes that I was allowed to for the presentation. However, this is just actually the first 15 minutes of what is an hour and 10 minutes and 24-second presentation. So if anyone is actually interested in seeing more of the history of the telescope and all, I will make the full hour and 10-minute version available. That maybe they can post that and people can watch that at their own schedule. All of this is based on my recollection of things, which may or may not be accurate. So if anyone sees anything that I've got wrong or whatever, please drop me a line at my email address there and correct me. And also, if there are any questions, you can also contact me there, and be glad to try to answer any questions you may have. Thank you.